This Motion Monday, working with drive parameters. If you've ever wondered how to see a drive value or how to set it, Copley has extensive documentation on the topic. If you go to Help, then All Documents, you will see a list of several help files. The two we will use here are the ASCII Programmer's Guide and the Parameter Dictionary. First, let's look at the ASCII Guide. We can see a list of ASCII commands here, as well as the description of each command. In a previous video, we used the R and I commands. In this video, we will use the S and G commands. The S, or set command, is used to set a value in flash or RAM. The syntax of the command is shown here. S for setting the value, R or F depending on whether the value is located in RAM or flash, the location of the value, and of course the value we want to store. The syntax of the G or get command is very similar, except there is no value to set at the end. Now, let's look at how to read the parameter dictionary. First, we will see the location of the parameters here. Because we are communicating over ASCII, we will always use this first column. Next, we see the column for bank. This refers to where the variable is located, RAM, flash, or both. Finally, we see the description of the parameter in the far right column. Now let's bring up an ASCII command line and try it out. Let's get the value of 0x127 from flash memory. And now from RAM memory. We can do either for this variable, as it is in both locations. Now we try 0x12a and get an error. We are looking in RAM, not flash, so we correct this and get our response. Great, but what does this value mean? Using Windows Calculator, we could switch to programmer mode. Then we can enter this value. We can then see the binary equivalent value here, but we can make it easier to read in Windows 10 by clicking here. This is bit 0, our LSB, or least significant bit. In our case, we're using a Sanyo-Danki encoder. The parameters for it are listed here. Bits 0 through 5 indicate the number of bits per turn, in our case, 17. Bits 8 through 12 indicate how many turns are absolute. Bits 24 through 27 indicate the encoder type, 4 or Sanyo-Danki. Bit 28 indicates the bit rate, and bit 30 determines if we treat a battery error as a warning. If we change the state of bit 30, we will get a new value to write to update the setting. Then we set the value to flash and get it again to verify it was stored. This can be done with any variable in the drive and can allow you to tweak values that you need after the drive was already set up, or verify drive settings that you needed to confirm. I hope you found this video useful for your application, and thanks for watching.